Okay, so today we're jumping into a craft that I promise, once you get it, you'll never look at things the same way again. We're diving deep into the wild, creative, and very, very chemical world of resin crafting. It's this amazing space where hardcore science and pure creativity just smash into each other. And for this deep dive, we're pulling from an amazing Spanish guide, Rosina Fossil, and a whole curriculum of professional course materials. All right, first things first, let's get one thing straight. You might see one of those beautiful, glossy river tables online and think, oh, it's just a fancy kind of glue. The reality? No. You are conducting a controlled and frankly toxic chemical reaction. Yeah, this isn't your average art studio. It's basically a hardcore chemistry lab.
Okay, so let's dive into the core reaction, which our sources have this really cool name for, the clock and the match.
So, what is this stuff, really? This liquid that somehow turns into solid stone? Well, at its heart, polyester resin is basically just a type of petroleum product. And on its own, it does nothing. It's just permanent goo. To get that incredible transformation, to completely change its molecular structure, it needs two buddies to kick things off, an accelerator and a catalyst. So, first, you've got the accelerator. It's usually a cobalt salt, and our sources have the perfect way to think about it. It's the clock. It's a timer. It controls how fast or how slow this whole hardening process is going to be. The second you add it to the resin, that clock starts ticking. But a clock by itself doesn't do much. If the accelerator is the clock that sets the pace, the catalyst is the match that actually lights the fire. You need that catalyst to start the chemical reaction, this thing called an exothermic reaction that generates heat and hardens the material. But here's the catch. Without the accelerator's clock already ticking, the catalyst's fire would either fizzle out or take weeks to work. It's this delicate dance between the timer and the spark. And when I say lights the fire, I am not kidding. This reaction gets hot. Seriously hot. The temperature inside that mixture can shoot up to 60 degrees Celsius. That's 140 Fahrenheit. The plastic cup you're mixing it in will literally get hot to the touch. And all this chemical action means this stuff has a surprisingly short shelf life. From the day they're made at the factory, you've only got about 6 months before they go bad. So unless you're cranking out projects left and right, buying in bulk, you're pretty much just buying future trash. Okay, that kind of chemical power demands some serious respect, which brings us to safety. And let me be clear, the rules here are not optional. We are, after all, dealing with a toxic and flammable petroleum product. The sources are crystal clear on this. You absolutely need open windows or a good ventilation system. If you're doing a lot of this stuff, you need a carbon-activated industrial mask. Disposable gloves are a must. And all that sticky, messy waste, it has to be sealed up in bags to keep those toxic vapors contained. And they are deadly serious about this next one. The vapors are harmful, so pregnant women are strongly, explicitly advised to stay away from the mixing and curing process entirely. Even cleaning up is a chemistry lesson. Now, what if you get some on your skin? Your gut reaction is probably to grab something strong like acetone, right? Wrong. That's actually a huge mistake. A harsh solvent just strips your skin of its natural oils and can actually help push the toxins deeper into your skin. The right way to do it is, first, use good old soap and water to get the bulk of the sticky stuff off. Then you use a cloth with just a tiny bit of acetone to get that last little bit of residue off, and then you wash again. So here's the thing. When we say resin, it's not just one single product. You have to think about it more like a tactical toolkit, where you pick the right tool for the job based on the physics of your project. For instance, you've got nautical resin, which is super tough. Think boat hulls or car repairs. For making jewelry, where you need perfect glass-like clarity, you'd want a pre-accelerated resin. If you're pouring a huge, thick river table, you need casting resin, because it's designed to handle the massive amount of heat from a big pour. Need to coat a vertical surface? Proggle is this thickened version that won't drip or sag. And if you want to make something that won't shatter, elastic resin has added flexibility to absorb impact. But hey, before you get any bright ideas about making your own indestructible coffee mugs, listen up. This is a huge warning from our sources. Resin is not food safe for hot things. Even long after it feels solid, heat can actually cause it to release tiny amounts of chemicals. So yeah, no resin coffee mugs or hot plates. So you've got your resin picked out. Now for the fun part, actually using it. And honestly, reading the instructions, it sounds less like a craft project and more like trying to bake a really, really picky souffle during a hurricane. The environment around you changes everything.
So the bottle might say, use 2% catalyst. But guess what? The weather outside has other plans. On a hot day, the heat in the air is already helping the reaction along. If you use the normal amount, it's going to overheat, get too hot, and probably crack. You have to use less catalyst. And on a cold day, it's the opposite. The cold air is literally stealing heat from your mixture, so you have to use more catalyst just to get the reaction to happen at all.
And this is where things get kind of wild and totally counterintuitive. The shape of your mold completely changes how fast the resin cures. If you pour it into a tall, skinny glass, it'll cure super fast because all that heat it's generating gets trapped inside and builds on itself. But if you take that exact same amount of resin and spread it out in a thin, wide sheet, it'll take forever to cure because the heat escapes right away. It's the shape, the geometry, that's calling the shots.
You also have to be super careful about what you mix in for color. The sources are very, very clear on this. Do not use alcohol-based inks. Don't use synthetic enamels. Why? Because the alcohol actually messes with the chemical reaction. It stops it in its tracks, and you can end up with a sticky, gooey mess that will literally never, ever harden. Okay, so I know this sounds like a ton of rigid, unforgiving rules, but here's the amazing part. Once you master them, you can start to bend the physics to your will for some incredible effects. These aren't just artsy choices, they are straight up hacks of the science. Want a marbled look? Easy. You just wait until the resin starts to get thick and gel-like, then you add your color, and just barely stir it. The resin is too thick to let the color spread, so you get these beautiful frozen ribbons. Or how about this? To get cool craters, you just drop a little bit of water onto the resin while it's semi-cured. Resin hates water, so it pulls away from the droplets, hardening around them and leaving these perfect little craters. You're basically using basic physics as your carving tool. How cool is that? And leveling a wobbly mold? Just stick some modeling clay underneath to make adjustable legs. It's a simple fix for a big problem. So what's the big takeaway here? Resin crafting is all about controlling chaos. You have to be as precise as a chemist, but when you respect those laws of science, you're rewarded with this incredible, indestructible material. It's only by mastering those super strict rules that you unlock total creative freedom. And that's really the magic of it, right? Once you get the chemistry down, you can take something delicate like a flower or a fleeting moment like a swirl of color and lock it inside this rock-solid shell forever. You're literally given the power to freeze time and matter. Which brings me to one last question for you. Since this stuff lets you create a basically indestructible time capsule, if you could pick just one object from your life and cast it in a block of clear resin to preserve it for 1,000 years, what would you choose? What one thing deserves to be frozen in time?